any object going away from you parallel to your eye line, which is also called your longitudinal axis, or your z-axis, right? That's a line out from your eyes. And so in this case, we're going to speak in terms of ground level, which would be something parallel to the ground. So anything parallel to the ground, or your z-axis in this case, like the sun traversing over the flat earth would be parallel to the ground, right? Or the stars or an airplane or anything else. Okay, so anything traveling away from you parallel to the ground will follow this law. The higher it is, the less it will shrink. So the higher and higher it is, the less and less it will shrink relative to its starting size. I will show you with this little experiment and prove it, and that's it. Let's go. Okay, here's a little experiment I did. I have two 4-inch diameter wiffle balls, and I put them on the ground, and I have a tape measure and everything. So the two balls are 6 feet apart, and the camera is a foot behind the near ball. So that makes the far ball 7 feet from the camera, and this ball is a foot from the camera. Okay, now you can see the far ball is about 1/10 the diameter of the near ball, and this would be your z-axis. Anything going away on your eye line, a line out from your eye in any direction, is your z-axis, and it will shrink a lot. But now, as I raise the camera up, you're going to see, look at that, voila. They're getting to be about the same size visually. I raised the camera up directly over the spot on the ground where I had the camera originally, and look at that. It's almost indistinguishable, just 7 feet up. So my law is, what I contend is that the higher the camera goes, or actually you can think of this as the balls going up. They're remaining parallel to the ground, but they're elevated. Kind of like the sun would do over the flat earth. It's moving parallel to the ground, but it's high up. So I've had so many people come to my videos, oh, the sun would shrink to a dot. And a lot of flat earthers say the sun does shrink. I'm not sure if it shrinks. I haven't seen any footage that shows that definitively. I have seen some that you could blame on blooming or flaring of the lens or whatever. And what I'm saying is, this is a fact. The higher up the object is traveling parallel to the ground, the less it shrinks. Because it follows the very steep convergence angles down, which essentially makes the sun or anything moving away from you start to travel perpendicular to your eyes and not on your eye line. And that makes all the difference in the world. Like I showed with the train going away shrinks. But when you raise the train up, now it's already shrunk the same size it is when it's far away from you. Okay, so here I have the balls next to each other, and you can see both balls have still traveled 6 feet away from the other ball. And you can see the higher up it gets, the less it shrinks. So there you go.
Make you cry. It's hard being sorry when we're living a lie. It's all over now. No, no, no. It's all over now. It's all over now.
You probably know neon for its use in lighted signs, but in fact all of the noble gases glow when they are bombarded with electrons.
I remember when I lost my mind. There's something so pleasant about that place. Even your emotions have a echo, so much space. Ooh. And when you're out there without care, was out of touch. But it wasn't because I didn't know enough. Just knew too much. That made me crazy. That made me crazy. That made me crazy. Love that you have in time of your life. Think twice. It's my only advice. Come on now. Who do you think you are? Ah, bless your soul. You really think you're in control? Well, I think you're crazy.
Hey everybody, this is a video about the sunbeams or the sun rays that come through the clouds called crepuscular rays. And what I'm going to do here is prove in this video with a series of proofs beyond a shadow of a doubt that the sun is close and the sun is small. First I'm going to show you an experiment I did with the sun rays that's very solid proof that the sun is in fact close and not very big. And then I'm going to refute Wikipedia's account of these crepuscular rays. They say that these rays are due to perspective and that in fact they are, for all intents and purposes, parallel lines from a sun that's almost 1,000,000 miles in diameter. But the fact that we see them splaying out, they say that that's due to perspective. I'm going to show that that's impossible. And then number 3, I'm going to show that it's actually, when you take a look at this picture of the crepuscular rays, that actually perspective is missing from this photo, if in fact the sun were 1,000,000 miles in diameter and 93 million miles away. The heliocentric model is in trouble. So let's get to my experiment. I watched a video from my perspective. His video is called Flat Earth Sunbeams, Part 1. I was outside and I go, man, let me try that. And I just kind of ran in, I grabbed some cardboard, I cut some holes in it, and I wanted to see how the sun reacts coming through. So here I am, raising it high over my head. So I'm about 8 feet away from this, and the light doesn't diverge or spread out. You know, it doesn't splay out like we see the crepuscular rays. And this sun's far away. Just like in the heliocentric model, the sun is far away, right? 93 million miles away from our clouds. But we see the sun rays splaying out from the clouds as though it were a close sun and not a faraway sun. Well, you can see when it is far away, the light beams are parallel and they don't splay out or diverge from the clouds. So then I got a little bit more sophisticated. I went inside and I cut some nicer holes in another cardboard. You know, my budget went up. And here they are, and I put some CGI here. I put some beams in there, and you can see they are dead straight. No splaying out. And then you can also, there's a part here where I have it up overhead, and I had the same results. No splaying out. So this is the example of the faraway sun, that the rays, this is what we should experience coming through the clouds. The rays from a sun that's almost 1,000,000 miles in diameter and 93 million miles away, when those rays get here, they should be parallel and dead straight. But we don't see them as dead straight. We see them splaying out or diverging from the clouds. Something's not right here. Okay, here I am inside. Notice I got my light close. Look at already you can see the light splaying out. You see that? I drew you can see the circles on the floor and on my piece of cardboard actually. Those are the original size of the holes that when I was outside they lined up perfectly. Here you can see them completely splaying out. And if I put the rays on it like this, the sun rays, and that's not even as splayed out as they got. It's just that the cloud is in view. And I want you to be able to see the cloud, which is my cardboard with the holes cut out of it. That way I could line up the rays. But as you can see, when I moved up a little bit off the floor and put the light even closer, the rays really splayed out. So I just wanted you to see that. Okay, so there you go. There's hard evidence that when the light source is close to the clouds, the light will diverge. The dispersion pattern you can see when I was outside, the dispersion pattern remained the same, meaning the 5 holes that I had, like that, stayed exactly the same, and that's a faraway light source. But when the light source was close, they splay out. That definitely supports the flat Earth model of a small, close sun. Okay, let's analyze this claim that science makes and Wikipedia makes that the crepuscular rays are due to perspective, that they're actually very close to parallel lines. For all intents and purposes, they are parallel coming from a sun that's almost 1,000,000 miles in diameter, but we don't see them parallel coming through the clouds. Those crepuscular rays are angled outward. They splay out. They're diverging from the clouds. And Wikipedia is saying that that's due to perspective. Okay, and Wikipedia also uses railroad tracks like these. And they say, see how these converge at your horizon, or they diverge from the perspective of the sun outward? And they're saying that that's what's going on here. Okay, so we need a quick little review of perspective. Notice in this long hallway, all parallel lines and planes angle to the eye level or the eye position of the observer. Notice that the side walls angle in, those are parallel lines to one another, and the ceiling and the floor are also parallel, but notice how they angle toward each other and they come to your eye level. All right, you have an X, Y, and Z axis. So the railroad tracks would fit your Z axis. That's going away from you, and those lines, yes, they converge. But the sun, and especially when the sun's overhead, would be bombarding us with huge vertical parallel lines, or rays, parallel rays. Yet, we don't see any of that, ever. So what I'm going to show you here is that this claim that these corpuscular rays is due to perspective is not true. It's impossible, because perspective will not converge or diverge or splay out lines or planes that are parallel to one another that are perpendicular to the viewer or his z-axis. Okay, so like in this picture of the railroad tracks here, the lines going away from you, that's I did with the green line, that's the railroad track, that's obvious. And right from the get-go, they start to converge. Now those are parallel lines, but yet we never see them as parallel. They're always converging as they go away from you. Now the black poles that I have going down the side of the railroad tracks are also parallel lines to one another. But notice that they stay parallel. They don't lose their parallel orientation. They may get shorter and they get smaller, that's true. They do have a sort of a convergence, but they don't change their parallel orientation, these vertical lines, because they're perpendicular to you. Now, this is why invoking perspective to explain the corpuscular rays doesn't work, because perspective does not splay out these vertical lines, yet whenever the sun is overhead, we should see vertical parallel rays everywhere, and yet we don't see them. So perspective as an explanation for this is invalid. You know, what we see is the rays emanating from this omnidirectional sun. The rays fit the size of the sun, and the angles of the rays off the sun also fit the size of the sun and the shape of the sun. But they shouldn't fit the size of the sun if the sun is in fact almost 1,000,000 miles in diameter and 93 million miles away. The rays should be huge and the sun small. So that's telling us that the sun is in fact close. Okay, and let's go back to what Wikipedia said. Wikipedia says that the rays from the sun are in fact parallel lines, but we don't see them that way because of perspective. Perspective splays them out. Okay, look at this picture. I put these rays in. Okay, so this is what's really going on, Wikipedia says. They say the rays are really parallel, and they would be from a 1,000,000-mile diameter sun. But this is what our eyes do through perspective. It splays it out. Okay, here's another one. They say this is how they really are. They're vertical and they're parallel, but our eyes splay them out like this. Okay, so then why doesn't perspective take these telephone poles and splay them out like this? We don't see that, do we? Why doesn't it take these buildings and splay them out like this? They're vertical and they're parallel. Well, because what we see, the corpuscular rays, is not due to perspective. It's just due to the nature of an omnidirectional light source with the light coming out in all directions. And it's coming from a small sun. It's impossible that this sun is 1,000,000 miles in diameter, as I've already showed you. So then if it's not perspective, these corpuscular rays are not due to perspective, as Wikipedia and science in general claims they are, then what are they? Well, it's very simple. All they are is radially propagated light. Or another way of saying it, light rays emanating out from a common center, like the sun, or any light. And I understand that the light rays coming off the sun looks like perspective. It shares the common trait where with perspective all the lines and planes converge at a point in the distance called your vanishing point. The sun also has that look where looks like the rays all converge at a point in the center of the light. Actually, the light rays are emanating out from a common center, but I can understand how they look alike, but they're not the same. Okay, that's all it is. And so, as we've already proved, that perspective can't explain the corpuscular rays, because where are all the vertical parallel sun rays then? They don't exist. Okay, so next I'm going to show you with streetlights and sunlight and how they look exactly alike. Okay, let's take a look at some light rays. Let's look at how the sun and a street lamp look the same. The one on the left is a street light, and the one on the right is the sun. Okay, notice that the light source and the rays match one another. And with the street light, that light is here on Earth, right? It's right there on your street. And those rays look in proportion to that light. They're also here, right? On your street or wherever you see that light. The sun, they're telling us, is actually far away, but the light rays are close. Like when we see these crepuscular rays coming through the clouds. And did you know that streetlights also have crepuscular rays, just like the sun does? And you know what? They look identical. Let's have a look. Here on the left, that's a streetlight, and those are crepuscular rays coming off of that streetlight. And they look identical. They are in the same proportion as our sun and its rays. And you can't say that that's perspective because they're right there. And as we've seen, perspective can't explain those rays anyway. So those rays are nothing more than radially propagated light. In other words, it's light coming from a common center. That's all. And look at this one. The left one is a street light. The one on the right are the sun rays. They are both in proportion to one another. The light source matches its rays, which indicates that they're both local. Okay, and this street light is here. We know it's here, and we know those crepuscular rays are here. There's no fooling us and telling us it's 93 million miles away or a million miles in diameter. And it looks just like the sun that they're telling us is far away and huge, and whose light rays are here, though, on the Earth. Same here. Same as what we see in the sky. The sun matches the sun rays. But in the heliocentric model, with a sun that's 93 million miles away and almost a million miles in diameter, the rays should be completely out of proportion, like this. You know, we shouldn't maybe even see the sun. Maybe the sun should just be a blob of light on the other side of our lit up atmosphere from these huge rays. I mean, we see the sun like it's in our atmosphere, like it's close, but it can't be, according to the heliocentric model. And next, I want to show you how, in this photo, perspective is actually missing. And what's ironic is the very linear perspective that they tried to invoke to explain this photo is actually missing from this photo for the heliocentric model to be true. Okay, so what do I mean by that? Well, I mean they invoked perspective to describe or explain these crepuscular rays, the fact that they're splaying out from the clouds, because they had to invoke perspective or something because this picture doesn't work for the heliocentric model. This picture of these crepuscular rays is a problem for their model because the sun is supposed to be a million miles in diameter. But the problem is they've invoked perspective, but perspective doesn't work because, as I've already showed you, it doesn't explain the parallel vertical lines that we should see all over the place. Perspective will not splay those out, right? So these vertical rays should be everywhere, the parallel vertical rays, but we don't see them. The perspective that's missing is like the sun is out there and it's almost a million miles in diameter, right? So its sunbeam, it shoots out a sunbeam, and that sunbeam is 100,000 miles wide, let's say. But what we see from here looks very small, right? But not when it gets here. When it gets here, it's going to be massive, okay? But yet, look at these sun rays coming through the clouds. They're small, they're skinny, they're tiny. They match the local sun that we see in the sky here. So that's what I mean by perspectives missing. And let me give you a couple of real-world examples to help you figure this out. Okay, now imagine you're at a football game, an American football game, and you can see the player, the quarterback, down on the field, and he's as big as a peanut, okay, on the field, even smaller. Okay, and the football is the size of a short grain of rice. And he's got this great arm, and he turns around and he throws that ball up to you in the stands, and he can throw it all the way to you. Now, I got a question for you. When the ball gets to you, is it going to be the size of a grain of rice, or is it going to be the size of a regulation football? Well, it's going to be the size of a regulation football, right? But that's not what we see in this picture with the sun rays. Those sun rays fit the size of the sun. And now let's take a look at this soccer player. All right, for those of you who don't know American football, there, he kicks it, he's far away, and the ball gets to you, it's going to be the size of a soccer ball, right? This is proper perspective. This is the perspective we're not seeing when we look at the sun. The sun that we see in the sky is close. Okay, here's a train leaving a station far away down the tracks. Also analogous to the rays leaving the million-mile diameter sun. Okay, the rays would be massive just like the train is massive compared to that little train station. Right? That's proper perspective. Now look at these shafts of light coming from the sun, the rays. The sun on the right here, each of its rays that you see coming off the sun would be about 100,000 miles wide. Just like this. You could fit 10 Earths side by side in that ray. Okay, so when we look at these rays, they're not 100,000 miles wide, and they're diverging out from a small sun that we see in the sky. I mean, that proves right there the sun is close and small. Now, I know somebody's going to seize upon this and say, hey, wait a minute, but we don't see perspective with the sun traveling over the flat earth. We should see it shrink to a dot and disappear. We don't see that. Well, I was going to save this for another video, and I maybe still will, but let me introduce to you celestial perspective. It's different than regular perspective that we're used to every day. Regular perspective, we see a train on the tracks, and as it goes away from you, it gets smaller and smaller and smaller until it disappears. But the sun, on the other hand, is different because the sun, when it's quote-unquote next to you, is high overhead and has already experienced a reduction in size. Now, as it goes away from you, it follows the convergence lines down to your horizon, essentially keeping it same distance from you. So the two movements offset each other. The one, the sun moving away from you, and then the visually lowering as it follows the convergence lines down to your eye level horizon. Also, the sun is too big to shrink to a dot anyway, right? It's going to go below the observer's horizon before that happens. Now note this about the convergence lines. Notice that on this wall of lines, the higher up they get, the more steep they get. They orient themselves away from the horizontal and more to the vertical. So the train on the tracks, as that goes away from you, it's right on your eye level. It's actually on your z-axis. Here's a picture of the z-axis, x-axis, and y-axis. It's on your z-axis, so all you can see is the train get smaller and smaller and smaller. You can't see any movement laterally or vertically out of that plane. But the sun is different because the sun, even though it's cruising over the earth parallel to the ground, it's on a much higher plane. So when it's overhead, it's already had a visual reduction in size. So now when it goes away from you and it follows those convergence lines down, it'll appear to be the same size because the going away and the lowering kind of offset each other. And same as this train. If you put this train high up overhead, that will cause it to already have a visual reduction in size also. So now when it goes away from you, it too will maintain its size. Kind of like if you're flying a kite, right? And you have the kite and it's a mile overhead, well, it'll appear a certain size, right? But let's say it takes a nosedive, but the string stays taut, so it goes all the way to the ground. Now it's a mile further down the road from you, but it's still the same size visually, right? So that's kind of how this works too. The weather balloon up to about 110,000 feet with a couple of cameras. What's remarkable about this footage is the sequence. It just passed about 4 minutes. Here you can see the sun right above the clouds. I mean, it looks so close. It does not look any 92 million miles away, that's for sure. And so it creates this sunspot, for lack of a better term, that most think is just the sun's reflection. What I show in my analysis is that it can't be the reflection of the sun, but is actually a projection from the sun itself. In other words, the sun is so close to the clouds that it is actually shining directly on the clouds. And that is what is creating that spot. Let's take a look. Okay, all right, there's the sunspot I'm talking about. Notice it never moves in its position in the clouds. It doesn't move around where a reflection of the sun would move around, which I'll show you in my experiment coming up. Right now, see, it's locked in its position on the cloud. It is not moving. It is moving, even though the camera's moving up and down, side to side, that reflection should be following the eye and the camera. Okay, the light above the door represents the sun. That's my sun. And the floor is the clouds, the tile floor. Okay, there's a reflection of the light that's above the door. Now, I'm moving the camera around, and notice how it moves. It stays between me and the source, which is the sun or the light above the door. Right? As I move left, it moves left. If I squat down, it comes towards me. If I raise back up, it goes back to the center, I go to the right, it goes to the right. In other words, so it stays in front, or it stays between me and the source, which it did not do in that video. There was no movement, which tells me that was not a reflection in that video. That is a spot from the light, and I'm going to show you that in my next. Here's a little bit more footage of my experiment with the reflection and spotlight next to each other so we can see how differently they behave. Let me set this scene up. I moved the flashlight over here close to the reflecting yellow light for a better comparison. I have the flashlight hanging over the floor producing the blue spotlight. The yellow round light on the floor is the reflection of the light over the front door, and the floor represents the top of the clouds. Notice that as I move the camera around, the yellow reflection moves all over the place, but the blue spotlight stays in the same place relative to the floor. Just like in the dog cam video, the spot produced by the sun stays in the same spot relative to the clouds and does not move. Clearly it's not a reflection of the sun on the clouds, but a projection of the sun's light due to its close proximity to the clouds. The small little whitish light is the reflection of the flashlight, and it too is moving around relative to the floor. Okay, have you ever been to the beach and walked along and the sun will follow you, like when it's shining off the water, or the moonlight? This is not a reflection. It does not move from its position in the clouds. That's a spot from the sun being directly over it. That's what it looks like. Like I've showed, it can't be a reflection.
All the ancient cultures and all the ancient texts describe a flat, motionless earth. So what happened? What changed? Who decided that the earth was a ball?
Map of ancient Egypt. I've inserted 2 sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the earth.
Wait a minute, how did Eratosthenes know how far away the sun was? To make this measurement, you have to assume the sun is extremely far away and that the sun's rays are parallel. But how do you look at things like this and get that the rays are parallel? Because it certainly doesn't look that way to me. If you look at the crepuscular rays of the sun coming through the clouds, you can see that it looks like the sun is right behind the clouds and the rays are emanating from the source of light, and those rays are not parallel.
Portuguese explorer Ferdinand Magellan became the first person in known history to successfully sail around the world. This circumnavigation of Earth soon became and continues to be touted today as absolute proof of the spherical Earth theory. If Magellan was able to sail east to west around the entire world and return to his original starting point, surely the Earth cannot be flat and must be a globe, right? Wrong. Just as a compass can place its center point on a flat piece of paper, trace a circle either way around, and return to its original starting point, so can a ship or plane circumnavigate a flat Earth. The only kind of circumnavigation which could not happen on a flat Earth is north-southbound, which to this day has still never been done.
The sailor thinks that he's traveling around the Earth this way, when in effect he's traveling around the Earth this way.
They began flying it around the world, from Abu Dhabi last year, with stops in India and China, then across the vast Pacific.
Does running round your neighborhood prove that the neighborhood is round?
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
And now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Yes?
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked.
What the hell is that?
It's where you've been living this whole time. Should we continue?
Uh-huh.
Flat Earthers, it's time. We are going to destroy the globheads' arguments concerning flight routes.
When you go onto the plane tracking software, you'll see hundreds and hundreds of flights over the northern hemisphere, and you can track those flights from beginning to end. When you look at any flight in the southern hemisphere, what you'll find is the flight takes off and disappears off the tracking.
A woman gave birth on a flight from Bali to Los Angeles, so the flight made an emergency landing in Alaska. Here's what it would look like on a globe. Now, here's what it would look like on a flat Earth. Which one makes more sense? Exactly.
Any map of the world is partial. It has a certain story to tell because we can never have an objective, consistent, real image of the Earth. We just can't do it. We can't square that circle.
All right, here's what looks like an objective image of the world. This is Google Earth, and it's a circular image, so it gets around the big problem of trying to portray the world on a flat surface. Now, you have a lot of reservations, don't you, about Google Earth? Yet, to many people, it's a wonderful application.
It is great technology, and that's what I first thought when I started doing the work on it. But I do now think that because of the way in which they have bought up so much of the data, which they fed into this geospatial application, is what they call it, they are monopolizing maps online. If you go online and you're using maps, you are probably using a Google map. And there's also some sort of sinister and worrying dimensions to Google because they buy Earth Viewer, which is the application, and that is funded by the CIA.
This is the company that they buy that provides them with the ability to produce this.
That's right, and first came to prominence because it was a great way of visualizing bombing raids in the first Gulf War. And Google saw that and thought, we're interested in that.
I mean, that's interesting that the CIA government had a hand in funding it, but it's sinister. You say, why is it sinister?
Well, because we don't know how those applications were then subsequently used for military purposes.
We've already discussed how there are no pictures of the Earth, so are satellites even real? Not likely. Ground towers are built all over the world and are more than adequate to relay our television, radio, and cell phone service.
All GPS is done through land-based towers, and things like Google Earth are taken with high-altitude planes, and most of them are just done with cars on street level. Did you know that satellites were actually invented by Arthur C. Clarke, the science fiction author?
I didn't know that.
they shortly became science fact after that. The geostationary satellite, look it up. It was created by a science fiction author. And then within a decade, NASA claims to have sent a real one up there, and ever since then, that's where we get all our communications from.
So if satellites were real, we would constantly hear stories of them being hit by meteors or comets, and that doesn't happen. No one's ever lost their direct TV feed during the Perseids meteor shower because one of the meteors knocked out one of the satellites. It doesn't happen, it's never happened, and it won't happen. And that to me tells me there is no satellites. You would constantly be worried about them, and you would constantly hear about them having something happen, and it's so rare that you hear that.
You could describe this as a glitch in the matrix, because what I've found is that actually there are events in history which have been somewhat covered up, it seems, because they don't really fit with the sphere Earth model. So these events that I'm talking about are radio broadcasts. If you look back through the history of radio, obviously radio goes back far before the time that we're told there were satellites and all sorts of other things. In fact, they go back to valve technology. Broadcasts are made from masts, and if you have a single mast broadcasting at any point on the Earth, should we say, if obviously it was a globe, imagine a single mast broadcasting. Electromagnetic radiation travels in straight lines. The mast would not be able to broadcast around the curvature of the Earth. Now, if you look at, if you talk to shills and so on about radio, then they will, and you say to them, how is it these radio broadcasts have reached, all this way around the world? They will try and tell you that there's relays all over the place. However, back in the early part of the 20th century, no such thing existed. When radio was first used, there were broadcasts done which are impossible in the sphere Earth model, and the powers that be have tried to suppress knowledge of this. So if you were to go to the Wikipedia page, for example, on the history of radio broadcasting, you wouldn't see anything suspicious. If you try to look back at the early history of the British public broadcasts, which were known as the Empire Service, you won't really be able to find any details, because there are people that have been working quite hard to put all this down a memory hole. The Empire Service was the precursor to what's now known as the BBC World Service, and the Empire Service was broadcast from the UK and was broadcast to the entire British Empire. Now, the British Empire, in order to reach all parts of the British Empire, broadcasting from London, you are broadcasting across the entire known world. This is impossible unless the world is flat, essentially, because how would any mast be able to transmit around significant parts of the curvature of the Earth? It's completely impossible. So the Empire Service was, in fact, proving by its very existence that the sphere is impossible. However, it's very difficult to find details on this. So I've been looking for some time, hunting around for proof that these broadcasts were made, proof which is still actually available in the public domain. And I finally found some interesting proof when I came across a documentary from 1953. Now, this documentary was about transistors, about how the invention of transistors was going to change everything, which of course it did. And in one part of the documentary, it starts talking about broadcasts that were made from Arlington, Virginia in 1915. Now, these were made from a set of masts, and these radio broadcasts were picked up in Paris and Hawaii, according to this documentary, which is produced by various firms, including, I think, General Electric. And this documentary in 1953, they must have realised after that this is one of the items they'd better hide away, because it's only recently that this 1953 documentary has been re-released and is available. So I was watching this documentary, and sure enough, it started talking about these broadcasts, and actually put up a little graphic map which I've snapshotted. And so you can see that they're claiming that these broadcasts were made in Arlington, Virginia, were picked up in Paris and Hawaii, significant distances around the curved surface of the Earth. And unless someone has a way to explain how these signals somehow reach their destination, I mean, no doubt shills will start talking about freak atmospheric phenomena and of weather conditions and God knows what. But actually, if you look at the history of these ideas that the atmosphere can interact with EM radiation, you'll see that those ideas were born after all of this, probably as a way to patch up the fact that it's completely impossible. Now, I don't think anyone has ever produced any evidence that radio waves, which you send up into the atmosphere, are going to get bounced down around the world, around the sphere of the world. What are they going to bounce off, and how does that work? And what is the evidence that there's any way for this to occur? It's just ridiculous. So I'm afraid they screwed up. They screwed up by being too proud of their worldwide transmissions, making a big song and dance about it, and then only too late realising that they just proved that the world is not a sphere.